we will see about our project. Project title is Continuous Temperature Monitoring and Thermal Management of Proton Exchange Membrane Fuel Cell. At first, we will see about the introduction of fuel cell. At first, what is a fuel cell? A fuel cell is an electrochemical energy converter that converts chemical energy of fuel directly into DC electricity. Next about problem statement. As the optimum working temperature of the fuel cell is between 60 to 80 degrees Celsius, the membrane will dry out if it exceeds this limit. This reduces the proton conductivity of the membrane, thereby affecting the fuel cell stack output. The need for the project. Maintaining the temperature of all individual cells within the safer temperature range, which in turn maintains the proton conductivity. Our proposed solution and objective is continuous temperature monitoring and thermal management using appropriate cooling technique. That is, we used air cooling technique in our project, and the deliverables of our project are the at the end of the phase one. Our deliverable is the air cooling system, as I said, and with the continuous temperature monitoring and thermal management for a 10 cell 200 watt fuel cell stack, which is available in the fuel cells lab. Uh, Next, we will see about the literature review. At, at first, we refer the literature about experimental investigation of the mechanism of variable fan speed control in open cathode PEMFC. And secondly, we referred about speed control of DC motor by using PWM. And at, at that, we read about experimental study on the temperature and the performance of an open cathode PEMFC stack under the thermal radiation. And lastly, we referred about a review on thermal management in proton exchange membrane fuel cells, the temperature distribution and control. From these we collected the inference of the from this literature, and we used it for our project. Next we will see about the methodology. In this we can see this fuel control unit. This supplies the oxygen as well as the hydrogen to the fuel cell, and this setup we can see that the thermocouples are connected to each cells of the fuel cell stack, and the temperature of each fuel cell stack is monitored with the help of this system. And these are the values we got from our temperature monitoring, and we have done observation in 4 different conditions. At first, we tracked the temperature with the cooling fan disabled, and next we tracked the temperature with the cooling fan enabled, and we did the same thing, but we varied the voltage from 7 to we changed it to 5. And this is the block diagram of our project. In this, we have an Arduino Uno L298 motor driver, SMPS converter, MAX 6675 module, thermocouple, DC cooling fan. In this, the thermocouple sends the temperature, and this information is given to the Arduino, and the Arduino gives signals to the motor driver, which controls the speed of the DC cooling fan. This is the brief working of our project. And as I already said, the components required are the Arduino Uno K-type thermocouple, MAX 6675 module, L298 motor driver, DC fan, SMPS converter. these are the images of our components, and this is the real setup, and in which we connected the all of the components, and this is the Arduino program which we dumped into the Arduino Uno. And in this program uh, we control the fan speed. If the temperature reaches above 40 degree, the motor speed will be around 255, and if the temperature is below 40 degrees Celsius, means the motor speed will be 100.